Testing, testing. Right, Math 0092. We are looking at section 3.6 today, multiplication of mixed numerals. So my first example is to look at a mixed numeral, 3 1/2 times 3/4. We're supposed to, well, our hint is to convert to fraction notation first. Now remember that fraction notation has a numerator and denominator. Mixed numeral notation has a whole number and a fractional portion. So we want to convert this mixed numeral to its fraction notation equivalency. So I have 3 whole pies sitting over in the corner cut into halves. So that'd be 1, 2, 3 whole pies and 1/2 of a pie. We know we have 1/2. But we have 3 whole pies. Now, if I cut those whole pies into halves, I have 1, 2, 3, 4, 5, 6, 7 halves. Well, I don't want to be drawing pictures and sketching with all of my work. So a quick way, what denominator do we want to convert our mixed numeral to? Well, in this case, it's halves. Well, 3 whole pies times 2 would give me 6 plus how many parts? So I have 6 whole pieces, or 3 whole pies cut into halves would be 6 halves, plus that little bit. And that's all times 3/4. Let's see, that's same denominator, so I have halves, and 6 plus 1 would be 7 halves times 3/4. And now, because I'm in fractional notation, multiplication of fractions is a piece of cake. You multiply the numerators, multiply the denominators. Eighths, I guess. We get 21/8. Let's try another one. 6 times 2 1/2. This is multiplication, and we have mixed numerals again. We have a whole number 6 and a whole number plus a fractional part. So converting to equivalent fractions, I'll have a whole number 6 over 1 times 2 times 2 would be 4 plus how many parts? 5 halves. So 2 1/2 is equal to 5 halves. Now we can multiply. Multiplication of fractions is a piece of cake. Multiply the numerators, multiply the denominators, and simplify if you can. 2 goes into 30 15 times. So 8 times 4 2/3. Well, our rule when we're multiplying with mixed numerals is to convert to equivalent fractions. So 8 as a whole number is 8 over 1 in fractional form. And 4 whole pies cut into thirds would be 3 times 4 is 12 plus 1, 2 more for 14/3. 4 whole pies cut into thirds would be 12. 3 times 4 is 12 plus how many parts? 1, 2. So I have 14/3. And now multiplying. Find a spot so it looks a little better for you. We have numerators 8 times 14 equals 112. Over 1 times 3 is 3. And looking to simplify, 3 goes into 112. Remember, this is a whole number portion now, 37. So 3 goes into 112. 37 times. 37 times 3 is 111, so I can get my remainder of 1. So 112 thirds is equal to 37 and 1/3. 2 and 1/4 times 3 and 2/5. We already have mixed numerals, so our rule is to convert to fractional format equivalents, and then we can multiply numerators and multiply denominators to simplify. So 2 whole pies cut into fourths would be 2 times 4 is 8, plus 1 more would be 9/4 times 3 whole pies cut into fifths would be 15/5, plus 2 more would be 17/5. 9 times 17 is 153. Multiplying numerators, multiply your denominators over 20. 153 divided by 20 is 7. 7 times 20 is 140. To find my remainder, I'm going to subtract, and I get 13. So my answer is 7 and 13/20. 13's primes, my answer is 7 and 13/20. Well, then we introduce division of mixed numerals. 2 1/3 divided by 1 3/4. Well, again, we're going to convert to equivalent fractional notation. So 2 and 1, let's see. Disregard that. We'll go over here. 2 whole pies cut into thirds. 2 times 3 would be 6, plus 1 more third would be 7/3, divided by 1 whole pie cut into fourths. 1 times 4 is 4, plus 3 more would be 7/4. So now I have 7 and thirds divided by 7/4. And whenever we're dividing fractions, we change division to multiplication and multiply by the reciprocal. So we're just kind of reviewing some things we already know. Multiplication of fractions is a piece of cake, so that's why we're making use of something we already know by converting division to multiplication and multiplying by the reciprocal. 7 times 4 in the numerator is 28, and 3 times 7 in the denominator is 21. Let's see, 7 goes into 28 and 21. 7 goes into 28 4 times, and 7 goes into 21 3 times. Our answer is 4/3. Division with mixed numerals. 1 3/5 divided by 3 1/3. Our plan strategy is to convert to fractions first, and then we can manipulate. So 1 whole pie cut into fifths. 5 times 1 would be 5, plus 3 more would be 8/5, divided by 3 whole pies cut into thirds would be 3 times 3 is 9, plus 1 more would be 10/3. So now we have 8/5 divided by 10/3. We remember that when we're dividing fractions, We change division to multiplication and multiply by the reciprocal. And multiplication of fractions is a piece of cake. We multiply the numerators, multiply the denominators, and simplify if you can. Now both 24 and 50 are even, so I know for sure 2 will go into both evenly. 2 goes into 24 12 times, and 2 goes into 50 25 times. So my answer is 12 25ths. Another example, 3 and 5/8 times 2/3. Here we're multiplying again, so we're going to convert our mixed numeral to its equivalent fractional form. 8 times 3 would be 24, plus 5 more would be 29/8 times 2/3. Multiplication of fractions is a piece of cake. 2 times 29 would be 58, and 3 times 8 is 24. 2 goes into each of those. 2 goes into 58 29 times, and 2 goes into 24 evenly 12 times. 12 29ths is your answer. Well, that was multiplication. Let's try 1 and 7/8 divided by 1 and 2/3. Here we're dividing mixed numerals. Again, we convert to its equivalent fractional form. 1 whole pi cut into eighths would be 8/8. 8 times 1 is 8, plus 7 more be 15/8, divided by 1 whole pi cut into thirds. 3 times 1 is 3, plus 5, 2 more would be 5/3. 15/8 divided by 5/3. Remember, now we convert in division. 5/8, we change division to multiplication and multiply by the reciprocal. And multiplication of fractions is a piece of cake. Multiply the numerators, multiply the denominators, and simplify if you can. Well, 5 goes into both the numerator and the denominator. 5 goes into 45 9 times, and 5 goes into 40 8 times. On page 192, most space shuttles orbit the Earth once every hour and a half. How many orbits are made every 24 hours? So we're looking at dividing into equal portions 24 hours. So for every 24 hours, how many orbits of 1.5 hours take place? Well, this is 24 over 1 and divided by 1 and 1/2. 1 whole pi cut into halves would be 2, plus 1 more would be 3/2. And remember, with division of fractions, we change division to multiplication and multiply by the reciprocal of the denominator. The reciprocal of 3/2 is 2/3. Multiply 24 by 2 and we'll get 24 times 2 is 48, and 3 times 1 is 3, and 48 divided by 3 is 16. So most space shuttles orbit the Earth every hour and a half. How many orbits are made every 24 hours? So in 24 hours, there are 16 orbits. Doubling a recipe. The chef of a 5-star hotel is doubling the recipe for chocolate cake. The original recipe requires 2 3/4 cups of flour and 1 1/3 cups of sugar. How much flour and sugar will she need? We have flour and sugar. The original recipe calls for 2 3/4 cups of flour, and the original recipe calls for 1 1/3 cup sugar. And we want to double it, which means times 2. Well, we're multiplying mixed numerals, so we're going to convert everything to its fractional equivalent. 2 times 4 would be 8 plus 3 would be 11/4 times, this is a whole number in fractional equivalent form, is 2/1. And multiplication of fractions is a piece of cake. We multiply the numerators, multiply the denominators. We see that 2 goes into both the numerator and the denominator. We end up with 11/2 cups, or 2 goes into 11, be 5. 5 times 2 is 10 with a remainder of 1. Or 2 whole cups plus 1/2 cup. Oops, sorry, 5. There'll be 5 cups. 2 goes into 11 5 times with a remainder of 1. So 5 whole cups plus 1/2 cup is needed if I double the recipe. Here we're going to do the same thing. Multiplying mixed numerals, we convert to its equivalent fractional form. 3 times 1 is 3 plus 1 more would be 4/3 times 2/1 in fractional form. Multiplying numerators, we get 8/3. And we want to know how many cups that is. Well, 3 goes into 8 2 times. 2 times 3 is 6 to get our remainder. So we have 2 whole cups plus 2/3 cups when we double the flour recipe and double the recipe for sugar need. (43) A car traveled 213 miles on 4 2/10 gallons of gas. How many miles per gallon did it get? We want to know miles per gallon. We were told that it traveled 213 miles using 14 2/10 gallons. Converting everything to its equivalent fractional format, 213 is a whole number, 213/1 divided by 14 2/10, that'd be 14 pies cut into tenths would be 14 times 10 is 140 plus 2 more, 142 tenths. Division of fractions, we convert to multiplication, 213/1. Change division to multiplication and multiply by the reciprocal of the divisor. Multiplying numerators, 2,130. Multiplying denominators, 142. So I'm going to use my calculator again, and remember it's going to give me a decimal format. 2130 divided by 142 is 15, unless it comes out evenly, as in this case. So when we travel 213 miles and use 14 2/10 gallons of gas, we were able to get 15 miles per gallon. Number 50. Find the area of each of the shaded regions, so from number 49 and number 50. So we're looking at the shaded region. We have 10.5 feet by 10.5 feet, so that's a square. And then within there's a rectangle 4 feet wide and 8.5 feet long that's not shaded. So we have this square 10.5 feet by 10.5 feet. And then within there's a 4 feet by 8.5 feet rectangle that's not shaded. So this area is shaded. So we're supposed to find the shaded area. Well, the area of the square, if I subtract that internal rectangle, the area of the rectangle, I'll have the area of the shaded portion. And we know the area of a square is side times side, side squared. So I have 10.5 squared for the area of the square, and the area of a rectangle is the length times the width. So I have 8.5 times the width is 4, and that'll give me the shaded area. Ten and a half is a mixed numeral. I'll want to convert it to its fractional equivalent. 2 times 10 is 20 plus 1 would be 21 over 2 minus, this is the area of our rectangle, and I have mixed numerals again, so 8 times 2 is 16 plus 1 would be 17 halves times 4 as a whole number over 1. Now remember, when we square, it's the number times itself twice. So I have 21 times 21, which is 441, over 2 times 2 would be 4. And here I'm multiplying. 17 times 4 is 68, and 2 times 1 is 2. In order to add or subtract fractions, remember your piece of pie, we have to have a common denominator, and we don't. So we want to convert 2 to fourths. I'll have 68 over 2. I want to convert it to fourths, so I'll multiply the denominator by 2 and the numerator by 2 as another name for 1. 441 fourths minus 68 times 2 is 136, and 2 times 2 is 4. Now I have my common denominator, so I can subtract my numerators all over the common denominator. And 441 minus 136 is 305. And we're going to want to convert that, so 305 divided by 4. And again, remember that your calculator is going to give us our decimal. And we're looking for just the whole number portion, so 76. And 76 times 4 would give us 304. And I can subtract to find my remainder 1. So 305 divided by 4 is equal to 76 and 1/4 square feet. So the area of the shaded portion is 76 and 1/4 square feet. We're going to continue with section 3.7. And in section 3.7, we're looking at order of operations and introducing complex fractions. One-sixth plus 2/3 divided by 1/2 times 5/8. Well, now we're looking at fractions, but multiple operations. So we have to remember, please excuse my dear Aunt Sally. Parentheses, exponents, multiplication and division from left to right, and addition and subtraction from left to right. So I'm looking for parentheses, there are none. I'm looking for exponents, there are none. Multiplication from left to right, or division. So we're going to do multiplication or division, whichever occurs first from left to right. Copy everything else down the same. 2/3 divided by 1/2. Remember, for division of fractions, we change division to multiplication and multiply by the reciprocal of the divisor, copying everything else down the same. And now from left to right, I have multiplication. Copy everything down. 2 times 2 is 4. 3 times 1 is 3, multiplying the numerators, multiplying the denominators. Continuing, I still have multiplication from left to right. Copy everything down the same. 4 times 5 is 20, and 3 times 8 is 24. I am done with multiplication and division from left to right. I'm looking at addition and subtraction from left to right, so I'm going to add 1/6 plus 24ths. But adding or subtracting fractions, we think about the piece pi. This one's cut into 6, this one's cut into 24, so we need a least common denominator. And I know that 6 goes into 24 evenly, so I'm going to convert 1/6 to 24ths. 6 times 4 would be 24, so I'll multiply the numerator by 4. 4 times 1 is 4, and of course 4 times 6 is 24, plus 20 over 24. Now I do have my common denominator, so I can add my numerators all over the common denominator, and 24 over 24 is another name for 1. So multiple tasks that take place when we are using all of our operations with fractions and mixed numerals. Next, we're looking at 7/8 minus 1/3 in parentheses times 48 plus, in parentheses, 13 plus 4/5, the quantity squared. Well, we obviously have multiple operators and parentheses, so we're going to call on our order of precedence. We're going to work within parentheses first, and we're going to find we have parentheses, but we do have exponents. So within our parentheses, we can resolve. We'll need a common denominator, and 8 times 3 is 24. So 7/8, 3 times 8 would be 24. I'll multiply the numerator by 3, minus 1/3, and we want to convert that to 24ths times 8. Multiply the numerator by 8. Still working within parentheses there. Keeping the parentheses, I have 21 24ths minus 8 24ths. 21 24ths minus 8 24ths, I can reduce that to 13 24ths. Copy this all down the same. So now I can work within the next set of parentheses. And the next set of parentheses, I'm going to copy everything down the same. I need to convert so I can add within the parentheses. I need a common denominator. So I'm going to convert 13 to fifths. 5 times 13 is 65. $48 plus. I can now add, I have a common denominator, and I'll get 69 fifths. But the quantity is still squared. So I have resolved everything within parentheses. I'm going to now operate with exponents. And a value squared, I'm going to have 69 fifths times 69 fifths. So 69 times 69 is 4,761. And 5 times 5 is 25. So I can check off exponents. What's next? Well, we're looking at multiplication and division, and this is 24 times 48. So that's actually 48 over 1. I can multiply numerators. 13 times 48 is 624 over 24, plus I can't do anything more with this in parentheses. It's resolved to the constant 4,761 over 25. Now 24 might go into 624 evenly. Let's see. 624 divided by 24 is 26. So I get 26 simplified. 25 won't go into this evenly. It's divisible by 5, and I need a 0 or 5. But I could find its whole mixed numbered portion. 25 goes into 4,761. Trying to find a spot where we don't have such glare. All right, so we're looking at 4,761 divided by 25. On my calculator, I get my whole number portion plus a little bit. So we know it goes in 190. 190 times 25 is 4,751. 4,750. And I'll subtract to get my remainder. 4,761 subtract 4,750, and I get a remainder of 10. Let's see, I better try that again. 4,761 subtract 4,750, and I get 11 for a remainder. I can see that 1 there, so it's 11 for a remainder. So I have 190 and 11 25ths. So now I can finish with addition and subtraction. 26 plus 190 as whole numbers. 26 plus 190 is 216. And 11 25ths. Next, we introduce complex fractions. And you're saying, oh no, they're tricky enough, we don't have to make them complex. But complex fractions means a fraction divided by a fraction. So a fraction divided by a fraction is actually in complex fractional form. So I have 7/3 divided by 2/1. Well, this is a fraction divided by a fraction in fraction notation. And we know to divide fractions, we change division to multiplication and multiply by the reciprocal of the divisor. That'd be 1/2. Multiplication of fractions is a piece of cake. Multiply the numerators, multiply the denominators, and we have our answer. 1/5 divided by 9/10. Well, this is a complex fraction. I have a fraction divided by a fraction. And we know that when we're dividing fractions, we change division to multiplication and multiply by the reciprocal of the divisor. Multiplication of fractions is a piece of cake. Multiply the numerators, multiply the denominators, and simplify if you can. Well, here our units digit is a 0 and a 5, so I know 5 will go in to the numerator evenly, and 5 goes into the denominator evenly. Complex fractions. Complex fractions, we have a fraction divided by a fraction. Two-thirds subtract 1/2, all divided by 1 7/8. Well, here we have some activity in the numerator, but in fractional form. And in the denominator, I have a mixed numeral, which we can convert to fractional form. If I'm going to subtract, I need to have a common denominator, and 3 times 2 is 6. So 2/3. 2 times 3 would be 6, so I'll multiply the numerator by 2. I'm going to subtract 1/2. 2 times 3 would be 6, I'll multiply the numerator by 3. All over, I'm going to convert this mixed numeral to its equivalency in fractional notation. So 1 pi cut into eighths would be 8. 1 times 8 is 8, plus 7 more eighths would be 15/8. In the numerator, 2 times 2 is 4/6. Subtract 1 times 3 is 3/6, all over 15/8. I can now add my numerators and get 1/6 over 15/8. And I have a true complex fraction, a numerator in fractional form and a denominator in fractional form. And to solve division of, I change division to multiplication and multiply by the reciprocal of the denominator. Multiplying numerators, and 6 times 15 . 6 times 15 is 90. Both are even, so 2 goes into 8 4 times, and 2 goes into 90 45 times. Harvesting walnut trees. A woodland owner decided to harvest 5 walnut trees in order to improve the growing conditions of the remaining trees. The logs she sold measured 7 5/8 feet, 8 1/4 feet, 8 3/4 feet, 9 1/8 feet, and 10 1/2 feet. What is the average length of the logs? Notice the word average. What is the average length of the logs? Well, you may have to review average. How do we calculate the average? You can look on page 73. So we're going to add the data set items first. 7 and 5/8 plus 8 and 1/4 plus 8 and 3/4 plus 9 and 1/8 plus 10 and 1/2. So we collected the lengths of each of the logs, and to calculate the average, we then divide by the count, 1, 2, 3, 4, 5. Notice the parentheses. We're going to add the data items first and then divide by 5. Well, we'll need to come up with a common denominator. I have 8, 4, 4, 8, and 2. 4 goes into 8 evenly and 2 goes into 8 evenly, so we're going to convert to a least common denominator of 8. Well, 7 and 5/8 is already 7 and 5/8. Converting 8 and 1/4. 2 times 4 is 8. 2 times 1 is 2. Converting 8 and 3/4. 2 times 8, 2 times 4 would be 8, and 2 times 3 would be 6. Converting 9 and 1/8, it's already in eighths. And converting 10 and 1/2. 2 times 4 would be 8, so 4 times 1 would be 4. There. Converted the data items in the numerator, all divided by 5. So now I can add my whole numbers. 7 plus 8 plus 8 plus 9 plus 10 would be 42. And adding eighths, I add the numerators. 5, 2 would be 7 plus 6, 13, 14 plus 4 more would be 18/8, all over 5. Well, now I have a mixed numeral over a whole number. Converting my mixed numeral to fractional format, I have 42 pies cut into eighths. 42 times 8 is 336. (42 times 8 is 336 plus 18 more eighths, be 354. 354 over 8, all divided by 5 over 1. This is a complex fraction, so we're going to multiply 354 over 8 times, change division to multiplication, multiply by the reciprocal. That's 354 times 40. 354 divided by 40 is 354 divided by 40 is 8 plus a little bit. 8 times 40 is 320. And I'll subtract to get my remainder. 354. Get a remainder of 34. So I get remainder of 34 40ths. 34 over 40, both are even, so I can divide by 2. 2 goes into 34 17 times, and 2 goes into 40 20 times. So simplifying, I have 8 and 17/20 feet is the average length of each log that she cut. A reminder to double check the definition of average. In order to calculate the average, you need to add the data set first and then divide by the count. The parentheses are very important. All right, return to D2L Brightspace for all details regarding, we're working in Chapter 3, homework, assignments, tests, and due dates. Thank you very much.